Water is critical for a country's existence. Pakistan is facing major water challenges, and the country needs to provide adequate water for agriculture, industry, and human consumption in the face of rapidly deteriorating reserves. These challenges around water management are impacted by climate change and an increasing need for sustainable economic development. Against this backdrop, the Center for Water Informatics and Technology has been established at the Syed Babar Ali School of Science and Engineering at LUMS. The center aims to serve as a hub with a focus on hydroinformatics and systems analysis while engaging the next generation of water practitioners and academics in multidisciplinary research teams and innovative technologies.
So this idea of looking at these water problems from the point of view of water economics is maybe the first step. So combine this with very fundamental scientific knowledge, the sort of scientific knowledge that we are very proud of sort of developing at our School of Science and Engineering. That does not just include hydrology and hydraulics as one discipline, but there are so many other scientific perspectives that can be brought in to really formulate these problems in such a way that can be translated into economic goals and so on and so forth. That is actually the first step. Now, in parallel, what we can do is that we can use these new information and communication technologies as these water communities beginning to call as hydroinformatics, meaning a marriage of hydro and information technology. And what that can help us to do is to actually come up with a lot of data, a lot of gadgets, systems, algorithms, methods to do what? Well, to look at every nook and corner of our river basins, to measure things very, very fast. And then that will actually generate the sort of information that can be integrated. And then that's the key third step. So we formulate the problems using good science in terms of good water economics, and then we come up with some key hydroinformatic tools to really look at these problems, to be able to play with those problems. And the third and the final step is really to synthesize all of this information. So how do we actually solve those problems using these hydroinformatics aids that we have, by which we are able to look at spatiotemporal problems at unprecedented scales, really. And what will be the outcome of that? Well, the outcome of that would be that once you look at all of this, and this process, by the way, is called as systems analysis or integrated systems analysis, in which we are discovering new critical pathways of how things are going around and interacting with each other. And as I said, the output of this would be what? Technology interventions. Well, these are the things that need to be done. This can also be policy advice, advice to the government, advice to the basin managers, advice to the agencies, that these are the steps that need to be taken by which the cost function that we have set up using water economics can be minimized. Now, I will actually go even further than this as a very grand objective for the center. Although whatever that I have just described is actually quite bold in itself. Now, the step further from there is that water, as I described earlier, is such a big problem and it has such big dimensions. It actually links with every other developmental problem that Pakistan faces, or for that matter, most of the world faces. And to be able to see these water problems alone is not really the way to go forward. And these water problems have interconnections, these so-called feedback loops, with all of these grand challenges from climate change, from food security, from urbanization, and so on and so forth. And this so-called nexus of water with food, with energy, with the environment, this is the way to look at these water problems in a sort of an integrated systems analysis way.